Welcome to another 4AC learning video. In this video, we want to follow through on topic 4 lecture on the 4.3 power factor correction. Now, in the earlier section, 4.1 and 4.2, we look at the various power and the power triangle. But one important thing is we need to look at how to do power factor correction. In other words, we try to find ways to reduce the reactive power Q supplied to a load and keep the power factor as close to unity as possible. So this will ensure the main bulk of the apparent power are actually used in being converted to other forms of energy. Now, what is this significant effect of power factor correction? The supply current is reduced. Right. You have to see that. You can see some example. When we improve the power factor to near to unity, the supply current or the magnitude of it is reduced, and this will lead to cutting down losses in the energy through the cables, the kilometers of cables that electricity or electrical power is brought to where we want to use it. Right. So remember, we have this formula: power is I square R. Right. And as long as we use this cable, copper conductors, which are actually also have resistance in the conductors, there will always be energy being used up along the way from the power station to where we want to use the electricity. So if we can find a way to reduce the I, the current level, since we already reduce our R, the resistance in the copper, by using very good conductors such as copper, by improving the power factor to close to unity, we actually effectively reduce the current that need to be delivered from the power station all the way to where the users needs electricity. So utility companies are able to save costs because there will be reduction in copper losses in the transmission cables and transformers. That is I square R being converted to heat mostly in the cables and the transformer. As a result of the lower current required, the utility companies can now use smaller size cable. Allows a more stable power supply, and as a result there will be spare capacity for the next customers and so on. Now, electrical power users, on the other hand, people like Ngee Poly, and we are, of course, we are small users, so we may not have the impact, but users like Ngee Poly will enjoy a lower price for power because they pay less for the power factor charge, and they need not lower price means basically is to reduce the penalty for low or poor power factor equipment. So in practice, how do we improve the power factor? Now, most electrical loads found in a system, for example in our Ngee Poly, are actually inductive in nature. Okay. So the load reactive power Q we saw earlier is the reactive power in the inductors minus the reactive power in the capacitors. So this can be reduced by introducing capacitive reactors. That means, how do we increase the capacitive power so that it cancels out the inductive power. So the capacitive reactive power QC is introduced by connecting capacitors in parallel to the load. Okay. Now, we'll be doing an example 4.3a to demonstrate how this can happen. So look out for a video for example 4.3a. There will be a few videos on examples 4.3a, b, c, and so on. So look out for those videos and for the more detailed explanation of how to address some of these AC circuits and how power factors could be improved. Bye for now.